right, we should be live. All right, so today we're going to talk about databases. I feel like I just left this room last night really late. All right, databases is, I would say, the most challenging part of this class, so we covered in a couple of classes. I'm going to go through the material from the book, go through some overviews of databases, and then if we have time today, I'll actually show you my database that I use for the 411 class. Some of you are my 411 class, right? Yeah, so the one that we used last night and started, was it last night? No, the night before. That will be what I'll show in this class, okay? All right, so I did see some chatter about the book. I have one copy that I can, if you sign it out for a couple of hours this afternoon, but if you don't bring it back, I'm gonna be very upset. Okay? So if you're still waiting for a book, I do have one copy in my office that oh shoot, do I have it with me today? It's in my car. I can get it from my car if someone is interested. Does anybody not have the book? Okay. Not yet, but you guys are working on getting it? Okay. If it comes down to it, I do have one copy that I can loan out. I just need to go get it out of my car, okay? But I do need it back. It's for my TA. So databases. Uh-oh. There we go. Okay, so hopefully, if you're paying attention, not sleeping, you will be able to understand what a database is, components of a database, what a database management system is, why do we use databases and when, what a relational database is, what an ER model or diagram is, and different DBMS operations in SQL. And that's pretty much the goals of this chapter. All right. Now, I will also probably ramble on about a few other things related to databases because there are different types of databases, and I might give you some context there. And I'll actually show you a real database that we use for the database class. All right. So, what is a database? You know what? Let's back up. Hopefully, not many people saw it. Does anybody tell me what a database is? Nobody? All right. I'll tell you. What's that? It is a place to store. Yeah. I'll tell you the official definition. My day is not good. Yesterday was awesome. Today, I'm not doing so hot. Man. But, that's my story of my life. Things tend to be like 3 good things happen, and then the next day 3 bad things. I'm not so sure I want to know what the 2 other bad things are. Yeah, and I feel like a slob. All right. What is a database? It's a self-describing collection of integrated records. Okay. So in a relational database, it's made up of, and you can kind of look at this from a hierarchy. It's got a table or file. So the top one up there, see if my little pointer works. That whole thing there is a table or file. Okay. A table or file is made up of records or rows. This is a record or a row. Okay. And then the record or row has fields or columns in it. Okay. And within each column, there are bytes or characters, okay, the smallest unit. So to give you an example, in the table, which we will call this the student table, okay, there are student numbers, student names, and final exam scores. Those are each a column. Now, each record is in there. That's a row in the table, okay? And within each record, it associates with these fields. So 1, 2, 3, 4, 5 is the student number. Jane Smith is the student's name, and the final exam's a 90. Within the student number, each one of these characters, or each one of these, excuse me, is a character. So 1, 2, 3, 4, 5, those are all characters. JANE, each one of those is a character, okay? So we can see how we build at a very fundamental level the structure of a database. Now, digging in here, here's another example with some more data in it. We have individual characters or bytes, we have rows or records, and we have columns, okay? And this is one table. Now, we use spreadsheets for data as well. So can anybody tell me when you would use a spreadsheet versus when you would use a database? Yeah.
Depends on your volume of the data that you're using and the complexity of the data that you're using. If you have data that's going to require multiple different entity types, so if you think about this because we have students, it's
Mhm.
the entity that's in this table. If you have students, but you also have teachers,
Mhm.
maybe you have staff members, administrators, you don't want that all in one spreadsheet
Right.
because it can get very confusing.
Can be very unwieldy. So I've seen examples of a finance department use a spreadsheet to manage the budgets. And you've got, gosh, we were probably around 6,000 people in the company. And there was one spreadsheet used to manage all the capital budgets. So anytime I wanted to go buy something, I had to get into that spreadsheet and indicate what I purchased. But finance had to get in there as well. It was a large spreadsheet in a company of that size. It would take maybe 2 hours to load up my machine and actually get up to be functional. Then there would be corruption issues and things like that. It was not designed for multiple users to use. So that's another place. So you mentioned themes. We call those themes. If there's multiple themes, we should use a database. If it's a single theme, we could use a database or we could just use a spreadsheet. Okay, so simple things like if all I'm doing is tracking your grades, I would use a spreadsheet. It's a heck of a lot easier for me to set up. Okay, but if I need to also manage, and believe me, I don't do this, I don't have the time. But if I were to track every office visit you had with me, every discussion that we had, every email that you sent, then I would use a database because I couldn't possibly track that in a spreadsheet. I could try, but it would fail miserably. Okay. So we use it for multiple themes. We also use it when multiple people need to access it. So historically, this class has taught Microsoft Access, and you end up spending all your time doing Excel and Access. We don't do that anymore. So we're going to use real systems in this class, and the real system we'll use, and some of you will do the database labs, some of you will not. Okay, you all should do the database design lab. It's easy, and I really need as many people as possible to do that one because we use it to assess the class. Okay, from a what do you call it? Oh my gosh, really bad. This is a second thing I'm forgetting. Accreditation. Okay, for accreditation purposes, but the actual implementation, they're a little bit more difficult labs. So if you are MIS majors, again, how many of you are? Because I don't remember. You're going to be seeing a lot of me. But if you are MIS majors, you really need to do the database actual implementation lab, or you're going to really struggle when you get to the upper classes. Okay, so do it in this class where it doesn't count for as much of your grade. All right. Now, I will show you that system in a little bit. So relational databases have several components. Metadata, tables, and the relationships between the tables. So I am going to draw a little bit on the board, not a whole lot, okay? Because I want you to understand some of these concepts, and I'll dive a little deeper. But please, this is so complicated. These concepts for a lot of people. If you don't understand it, stop me, and I will try to explain it a different way. Okay. This is the unit where a lot of people struggle, and it is something that's tested. Okay. So let's start with relationships. So let's say I have a table here for students. Okay. And in that students table, I have a few columns. Okay? I have your student ID. I have your name, and we'll just make it easy and just have one name field. I have your email, and I have your final course grade. Okay. That's my students table. Now, actually, I shouldn't say final grade. That's your GPA. Okay. We'll call that your GPA. Now, I have other data that's related to you. Every one of your professors has to have something related to the professor and the course because your course has different scores that add up to be your GPA. Well, what we don't want to do is go and start putting courses in here. We don't want to do this where we say course 1, course 2, etc. That becomes unwieldy. Now we're talking multiple themes of data. We also add in the professor's name and the professor's number. This becomes a really unwieldy thing. This would be a spreadsheet. We don't want to do that. So what we do instead is we create a new table for a different theme of data. And we can say this one is MIS304, okay? And this one would be your, let's see, we'd probably have, think about how I want to do this. I want a unique identifier. So actually, I'm not going to do that. I'm going to call it the course table, okay? This is the course ID. And the course name and the professor, okay? ID, we'll call it. Now, I'm not going to put the professor name in here. I'm going to tell you why in a second. I'm going to create a separate table now for professor. Okay. And in the professor table, I'm going to have a professor ID I'm going to have a professor name, and we'll keep it simple, and course 1. Okay, so course, actually, we don't even need that. Let's just keep it simple with those fields. Okay, there are relationships between these tables. Okay, each of you are in a course. Each course is staffed by a professor, which means then you also have a relationship with the professor, but this course is what ties your professor records and your student records together. Okay, and so the way we do this, and I will describe this a little bit more in a second, is we have a unique identifier. So here it's your student ID. Here it's the course ID. Every course has a CRN number. Okay, it's unique for every course. Then every professor has an employee ID. Those are the unique values. Okay, every table has to have a unique value. Otherwise, it's going to be very difficult for us to go query it for information, because if I just had names or something, there could be 2 John Smiths in there. They're totally different people. Okay, so that's why we have to have some sort of unique identifier for everybody. Now, how do we do these relationships? We use this thing called an ER diagram, and I will get into this a little bit more in depth in a minute. That will show it on the board, and you'll see clearer lines, but I just want to explain it at a higher level. We have to map the relationships, okay? This simple example, these three tables are connected in this manner, okay? Now, in a more complex manner, they could be like, this one could be connected to this one maybe, okay? That happens, okay? But in this case, let's say we have student ID, and we have 1, 2, 3, 4. We have John Smith. Okay, we won't put their email in there right now, and they've got a 4.0. Okay, and they're in course ID 12345, which is MIS304, and the professor ID is 54321. Okay, and the professor ID here is 54321, and this is Underhill. All right. In each one of these tables, this unique identifier we call a primary key. So the unique identifier is called the primary key. So the primary key in each one of these is this one here. So we abbreviate that with PK, PK, and PK. But that doesn't do the relationship. That's just to show what the unique identifier is in this table. How do we relate them together? We use a different type of key called a foreign key. Okay. And so with the foreign ID or foreign key, what we do is we build into our table another column here. In this case, called course ID. Now, I want to stop here and say, just because I have something with the same name and the same data in it does not mean that it's duplicated, okay? What this allows us to do is say 1, 2, 3, 4, 5 is the course ID that you're in. Okay? This is a primary key for this table, but it's actually, there's a key here called a foreign key, okay? Foreign key. And let me give you an analogy of a foreign key. We all have a Mac or a Windows machine, right, in here. Anybody have Linux? Okay, do you have Windows as well? No? Okay, well, use the analogy of whatever it is on Linux. The start Windows menu on a Windows machine or the Mac OS bar, okay? We all know what those are. When you install an application, you can drag a copy of the icon down there, but it doesn't actually, it's not installed on the mini bar at the bottom, right? It's just a pointer to the real location on your computer where the application's installed, okay? That's the same sort of thing as a foreign key. We're not actually putting the actual data in this table. It's still stored in this table for this key. And for this one, it's actually still stored in this table. It's just a pointer, okay? This is just a pointer for professor ID. And it says professor ID is actually the professor table and the professor ID field. That's what a foreign key does. It just basically, excuse me, points to another location, okay? So if I go here and I look at students table, course ID is just a pointer saying I'm in the course table, course ID here. So then the data here, you see it here if you do a query, but it's not actually stored there, it's stored here. Okay, so we don't need to duplicate data. Now the reason I do that rather than put the professor's information, like the course name or something, is there are multiple courses with the same name. What if I put a space in the name and I don't do it? This is where you can end up with data issues. And the example that I like to use is not this particular one. Let's say your accounting department in the beginning is just called accounting and finance, okay? So in the beginning, it's called accounting and finance. You grow and you split those departments up into accounting and finance, okay? Two separate departments. If you go and put something like a non-unique identifier in a table like that, and you add it to every single record, you might type in accounting and finance, you might type in accounting, you might type in finance, but you actually mean the same department, okay? So then you end up data integrity issues. And now you do a query for accounting, you don't get the accounting and finance or the finance people, okay? But if you use a unique identifier and then you have a table for all the department IDs, you can map it. So then you say, department 1 is accounting, 2 is finance, okay? And originally it was, maybe 1 is accounting and finance. All you do is update this one field. And if I was in the accounting and finance, so we just do like department ID here. Okay. If I update that table and I have a 1 in it, I don't have to go change every single record in the database where I use a department name. Right? I can just say department 1, and then when we move people around, we just change it in this table. So this would be another table department, basically. Okay. So these relationships we show using what's called an entity relationship. Each one of these tables, when we're doing a a data model, we call these entities, okay? So entities is effectively the same thing as a table here, okay? Now, each one of these entities has a relationship with another. So the way we do that is with this thing called cardinality, okay? Cardinality. And we use maximum, and then there's minimum as well, okay? Oops. And so what we do first is we look at maximum. And so maximum has 2 different symbols we use, okay? One is basically this thing that looks like a crow's foot, okay? The greater than less than symbols, basically, okay? Depending on which end of the line it's on. And the other one that we use is the pipe symbol, or on Windows keyboard that's at 2 lines on top of one another, okay? So it's right above your return key. And on the Mac, it's a straight line, and on the PC, it's got a little space in between it, but it's the same character, okay? Now, on the minimum side, we use 2 characters as well. We use that same line symbol, and we also use an O, okay? I'm going to tell you what these mean. So these particular symbols, this means many, and this means 1, okay? This one means 1, and this means none, basically. Okay? Hence, it looks like a 0. Okay? So when we look at cardinality, we first say, okay, look at the students first, reading left to right. Okay. The student's relationship with the course. Okay. A student can have a maximum of how many courses that they take per year. Is it only 1, or is it many? Many. Okay. So we say that they have a many to 1 relationship, or sorry, a many relationship on the maximum side. Now, what's the minimum number of courses that a student must take in order to be an enrolled student? Let's just assume 1, right? So there's a minimum notation of 1. We're 50% done with that table's relationship. Now, looking at the course, okay, a course, what's the maximum number of students that you can have in a course? Is it many or 1? Many, okay, so we do a very similar thing here. What's the minimum number in a course in order to hold the course? Is it 0 or 1? 1, right? So now we know that this is a many to 1 and many to 1 relationship between these 2 tables, okay? And so if I were to go read this, I'd say, oh, okay, well, there's the maximum cardinality is there can be many relationships, and the minimum is there must be at least 1 relationship. Boom. Okay. So now I know how those tables relate. Now let's look at it from this side. On the course side, every course can have a maximum of how many professors? Let's just say 1. I know that there are some courses where I might team teach with Professor Sun, but I'm really only there for 1 or 2 units. I'm not really the assigned professor, okay? So we'll say there's a maximum of 1. Okay. Now, every course, does it require a professor? Yeah. Well, let's put aside senior experience, which has an advisor, and independent study, which still has an advisor, okay? So it has a minimum of 1. So now we have a double line for that relationship. Now looking at it from the reverse. Professors what's the maximum number of courses they can have? They can have many, right? So we do a many symbol. What's the minimum number for a professor? Okay. If they're active, yeah, one. So just for the simple sake, let's just say one. There could be people who are on leave or something, but let's just say they're minimum, they have to have one. Okay. So now we know the relationship between these tables. And we can depict it in a drawing like this, which I'll show you a better one because this is pretty crude. Okay. Now the metadata is very special. So we've got some data here, and let me show you what the metadata looks like, just so you can see. This is called an integer. Okay. It's a whole number. Oops. And we abbreviate that in the metadata. It's usually called int. Okay. Now this is a different type of data. This is called a string. Okay. But in some databases, like the one we're going to use, it's called a varchar. Okay. Stands for variable character. Okay. Now email address would probably fit into a string data type as well. So string is anything that I can put in, say, quotes, and it could be a sentence, it could be an email, it could be just words. It can also be numbers. And let me tell you why this is a little different. If you put a number in as a varchar or string data type, you can't do any type of mathematical operations. You can't add, subtract, whatever number on it. Okay. Now, if it is something like an integer, though, you can. If it's a decimal, you can. Yes.
So with regard to having a number in a string, that means it's just the literal characters.
Yeah, exactly. Yeah. So if it's 50, it's a 5 and a 0. Yeah.
So when it's stored like that, it doesn't have a numerical value.
Exactly. Yeah. Yeah. GPA would probably be a decimal type. Okay. This one, varchar. Some databases actually have a special data type for email addresses, but not all of them, right? And then course ID would probably be another integer. Okay. That's one aspect of the metadata. Another aspect is the key type, primary key, foreign key. Okay. And in the database that I use for the example, PRI is how they abbreviate primary key in the metadata, and then foreign key they call MUL. I don't remember why it's called MUL. It's kind of weird to see it. You'd expect foreign key, but it shows MUL. Okay. Now, there are a few other pieces of metadata that you might see. One of them is this one called null. Okay. And what null means is, do I have to enter data into that field? Okay. That's the question. So if I have to enter data, then I say no. Okay. So data is required. It means it can't be null. Okay. If I answer that question with yes, it's basically a Boolean value, then data is not required. Okay. So and here's an example. I could enter this data, and if this field is required, it says null, and it says, going back here to yes, okay. Oh, sorry, hold on a second. No, okay. Then I have to enter a student ID. But I don't have to enter an email address. Maybe that one's not required. Okay. Another type of data, metadata, is auto increment. Okay, can anybody tell me what you think auto increments for? Any ideas? Kind of, yeah.
Is that where you're, when you send somebody up to the database, or say you're adding a new student,
Mhm.
it'll automatically generate a student number?
Yeah, exactly. Yeah.
Some increment either
Yeah,
way.
we'll auto increment whatever value. So in the past, we used auto increment in databases, but I'm going to say that this has fallen out of favor from a design perspective, and here's why. If you do auto increment on a database that you have one write database, one that writes, and maybe you've got some that you can read data from, but you can't write it to, this isn't an issue. Where it becomes an issue is at web scale, where you have maybe 10,000 databases that are accepting writes around the world. Okay. Now, how do you keep track of that increment in the database? How do you prevent someone who goes into this database, it auto increments, someone else writing to a different database in a different data center, and now it's auto incrementing, and maybe it assigns the same number. Okay. So nowadays, this is typically handled in your application. So your developers handle it in actual application, whether it's JavaScript, Python, whatever, they use the functionality in that. So generally, we've moved away from doing auto increment in the database, and we try to just use the database to store data. Okay, we don't let that. We try to remove all the business logic from the database and let the database just handle the data itself. Okay. Yes. Yes.
which one is?
Oh gosh, sorry. Data is not required for the second one and can be null. That might be clear. Can't be null for the first one. There it says no. I kind of wrote that weird. All right. All right. So we've got metadata, we've got tables, and we've got the relationships. Yes.
So when you for the null section, is that when if you're filling out a like email survey or something,
Yeah.
or signing up for something, those red asterisks for the required ones, that's null is no on there.
Yes, sort of like that, but that's the website of it. So that would be defined in the actual application logic, not the database. This specifically, if you try to do this from there, you would get a really obscure database error if you didn't build it into the logic of your web application to require those fields. Because you would submit it, it would give an error, it would throw back a database error to you, and then your user would get an unfriendly message. So you try to handle those types of exceptions in application. Yeah. But this would be also for if you're doing it through the SQL interface using SQL. If you try to do this, and let's say I require that you do the student ID field, and you didn't put one in, you would actually get an error back when you try to insert it into the database. It would say that it's required, you can't do it. You've got syntax error. Okay. All right, so metadata. So let me show you some examples here. So this is the auto increment that I mentioned. Okay. Oh, here's one other that I forgot to mention. So the default, you can set it where it has a default value. And so the default value could be just null. You could also set this field to be a specific value if you want it to be a default of, true or false or yes or no, or whatever you want that default to be. But generally we don't do that. That would be not a good thing. So here's the primary key and the foreign key, and then there's that null field. Okay. So this one can be null, this one can be null, but the advisor D has to exist. Okay. All right. Integers, there's some examples up there and strings down there. So there's data types are one type of the metadata, the keys are another, and then the other fits into all these other categories. Okay. This is an actual table, by the way, in a database I used to have up. Okay. It was called the advisor table. You can use the describe command in SQL, which hopefully you have some interest in learning SQL. There are free SQL books online through O'Reilly in the library. Okay, so if you go to the library and you search for O'Reilly or Safari books, see the library here? These books are all free. Okay, all sorts of books, tech, marketing, I don't know what else, other business books. Okay, and there's SQL books out there. And if you're in the database class, you already know what I'm talking about because we have those books we're using in our class. But if you're not in that class yet, pretty much any book you ever want to read that's on a technical subject or some business subjects, you're going to find information. It's all free for you while your student's here. When you leave, it's like $40 a month or something like that. It's pretty expensive. All right. SQL is something that will differentiate you on your resume, by the way, especially if you're going into, well, I think if you go into any field, management, marketing, finance, MIS, whatever it is you're going into, knowing SQL is a very valuable skill for you to have on your resume. And it's not that difficult to learn the basics. Okay, to pound out the basics, you could probably get through the introductory material, learn basic SQL in a week, maybe less, depending on how much time you put at it. So think about that over summer. It could be something you do over a week over summer. Now you can put it on your resume. You've got SQL skills. Okay, that's just a very simple SQL command. Describe advisor. Describe the table advisor to me, and it just pops out and tells you what the table looks like. Okay. Things like insert allow you to insert data. Select allows you to search for data. Okay, like find data in the database. So this is sort of like what I just showed here, the relationships between these tables. Okay, there's not a direct relationship between a student and one of the employees, but there is a relationship between the student and a course and a professor in a course. Okay. Right, so we have entities like this, and we have the relationships like this. Okay. Entities are things we track: students, courses, departments. Okay. Attributes are these things. So these are the attributes. Okay. When we go, so this is a data model, by the way, and this is all a data model that I'm showing you. Now, after we build a data model and we decide this is what we're going to build, the next thing we do is a design. Okay. And the design where things happen is basically that the entities, so this is the entity name, that becomes, did I write this down already? Okay, entities become a table and the attributes become the columns, okay? So that's when you go from, this is the data model, and this is the database design, okay? And so then this becomes the columns. And then the identifiers are these things. Okay, this is an identifier, and this is an identifier, okay? All right. So the identifier just uniquely identifies an entity. Now, I showed you the cardinality. You can take a look at this. Okay. We just did that as an exercise. All right. So this is the data model. Now we're going, by the way, does everybody have this in easy? You can take a picture if you want to. Okay. Might be helpful. And then I'm going to erase this and show you the database design for this exact same data model. Okay. I'll get out your picture. All right. All right, so we're going to go ahead and erase some of this stuff, clean up the board a little bit. And now we're going to take what we have here and turn it into an actual design. Because we don't want to, one of the things that some people do is they just go out into the computer and they just start creating a database. And the problem with that is, yeah, you're tinkering with it, but the problem is the database design can get pretty bad. You didn't think it through first. And it's easier to change the database before you implement it than after you've implemented it and start writing data to it. It's a massive undertaking. This is why it takes companies a long time. If they make a major change, they have to redesign their application, which is costly and takes a lot of time. So unfortunately, this is one of the deficiencies of relational databases is you have to think about it all in advance. And if you want to change it later, it's very difficult, okay? There are other databases where you don't have to think it through ahead of time. They're more flexible. So an example would be the MongoDB lab that we have out there. That's a non-relational database. It's called a document database. For every single item, it has its own document, and it has a structure, and that structure can change over time. It really doesn't matter. Okay. So if I want to add a field, I just add it to new records going forward. And I can go back and retrofit old records, but it doesn't really matter. So let's say instead of email in 5 years, we have a virtual reality address we all have, right? We all have virtual reality boxes in our house or something, okay? I'm thinking, okay, maybe 5 years is up, 50 years, okay? If we had something like that, we couldn't have fathomed that when we built the database originally, right? So we just add it, and then in the future, we do it. And if we update data in the future, we can add it to people that, as they get it, okay? We don't have to think it through. There's no concept of relationships that we have to worry about, okay? Everything's a standalone document, all right? Okay, so let me transform this into a design, okay? So let me start with students, okay? Okay, so for students, what we do is we just draw out a table, just like we did before, okay? But now, this is the students table. Okay. We have the student ID. We have the student name. Okay. We have maybe their email and their course ID. So let's say I skip GPA for now, make it simple. Okay. Then we say that this is the primary key. Okay. This is the foreign key. Okay. We say that this is a integer data type. We define this as a varchar. We define this one as a varchar. And we define this one as an integer as well, okay? Okay. We've completed the design of that table. We would then go do SQL to create it in the database, okay? Now, then we'll do the course ID table, or the course table, excuse me, course table. Same sort of thing. We have the Course ID, it's a foreign key, or sorry, primary key, my bad. Primary key. It's an integer. Bless you. Course name, that is a varchar. And we have a professor ID here on the end, okay? The professor ID is an integer and it's a foreign key, okay? We now have our design for that table. Okay? And the last thing we do is we fix the professor table here and we create that one, okay? So for the professor table, we again do this. We have the professor ID. That's a primary key. It's an integer. Okay? Then we have the professor's name and whatever else we want, varchar. Okay? Now, this is our design. We finished it. Now we could just go start creating records in it, okay? So every time we create a row, it just creates a new row in that database table, okay? Every time I insert a record. Now, behind the scenes in the SQL, I have to build when I actually, SQL is what I use to create the database. Now, the lab computers in here, actually not the lab computers, Cougar Apps has a program called Heidi SQL, okay? It's a graphical way to build databases. It's on Cougar Apps. If you're Mac users, PC user, doesn't matter. I don't know about Linux though. I don't know if it works with Linux, but Windows and Mac work, and you can go into it from the lab computers here or your own computer. You can go into Heidi SQL, you can connect to a database, and you can actually go create the data, okay? If you use, either way, if you use that or SQL, what it ends up doing is behind the scenes when you do the SQL or build it in the application, it maps these relationships for you through SQL code, okay? So it points this foreign key to this primary key, right? When that's all done, you can just start entering data. Now, let's just say later on, I decide I need to add another table for something. I have to go through a process called normalization. That's what I was talking about. If you don't think this through ahead of time, it can lead to problems. So those of you who are in the 411 class, when you're working with your groups, you're going to be thinking it really through before you do any implementation because of that reason. You don't want to be the person who goes and builds your database and has to go redo it in the middle of it. Okay? That would be, rework is worse than just doing it right the first time. Okay. Now let me tell you a quick story along these lines of why this is important. Okay. So I had this boss, and I mean, she was nerdy, I guess, too, but apparently her husband and her son were extremely nerdy. One worked at Google, the other one worked at Berkeley as a professor. Okay. And they decided to have a contest on the weekend of who could write the best code in a hackathon. Okay. I don't do that sort of thing, but I'm not that nerdy, I guess. Okay. So they go and they have this hackathon, and the husband sits down and he just sits there and he thinks. And the son's meanwhile typing as fast as he can. Okay. They get to the end of the time and they looked at each other's code and she judged it. Okay. The husband's code ran better, was cleaner, and he did it in like 30 lines of code. And the son went and did it. He spent the entire time coding, not thinking about it. He had like 1,000 lines of code to do the exact same thing. And in programming, the less code, usually the better, okay? It's more efficient, uses less memory, that sort of thing. So the lesson is, if you take the time to plan, you're going to have better success than if you just try to start doing something. Okay? Same thing with anything in life. Like, you go on a road trip. You're less likely to run into issues on a road trip if you plan it out ahead of time. Figure out your routes, look for construction, map it out, see how long it's going to take, book your hotels along the route, that sort of thing. If you wait till the last minute, you just get on the road, follow the GPS, you might encounter construction you didn't anticipate. You might get to the only hotel in town and they have no space available, okay? So planning usually is better than doing things ad hoc. You have a question?
I was going to say, I'd seen a quote once that said something in a similar light, that if you've got an hour to save the world, you spend 59 minutes thinking about how to solve it, and then take that last minute to resolve the problem.
Exactly, yeah. Okay, so that clock is always an hour fast. It always throws me off when I look at it. Okay, so normalization, we convert poorly structured tables into two or more. So we start breaking up those. So as part of the design process, we might map this out, okay? And then later on, as we're going through the design process, before we implement, we start saying, what about this one? Should we really have the contact information for the student in the same student table. Maybe we need a student contact table. So that's what normalization is breaking it down. And you want to try to get it down into a single theme of data per table, the smallest unit possible, okay? And then define the relationships between them. And the reason for this is it minimizes a lot of the data integrity problems we had. I mentioned earlier with accounting, finance, that can be a huge problem, okay? Now, model to design, entities become tables, entity identifiers become the table key, entity attributes become the table columns, and then you show the relationships with the foreign keys, okay? This is just what I said earlier about primary keys and foreign keys, oops. Okay. So data integrity problems, you can have incorrect information, inconsistencies in your data. Here's a real life example. Let's say I work for a company and we grant terms to customers. Everybody know what terms are in business? Anybody not? Just, I'll tell you. All right. Okay. I'll tell you then. So terms are credit basically. I send you an invoice for the services I provide and you pay it within a certain period of time. I've already performed the work. Okay. If you grant credit, that's called terms. And generally it's net 30, which means the net balance of what you owe is due in 30 days from the time you get the invoice. Okay. Some companies give you longer, some give you fewer. I personally, payment is due upon receipt for my business. And then I still have customers who don't pay me on time. So you want to make sure that you consider that. Well, so going to my issue here is, let's say that sales is really trying to close a deal before the end of the quarter. Anybody in sales in here? Nobody. Okay, one person. All right. So you got to close the deal before the end of the quarter. You want to make your numbers, right? And so you really want to sell to the customer. You trust the customer. They tell you that, yeah, we pay our bills on time. And you don't think anything of it, right? So you go into the system and you say, yeah, I'll go ahead and approve that order to get shipped to you. Okay. But they haven't paid it yet. If you have data inconsistencies, then what happens is finance has a different picture of data than you do. Okay. So finance knows they haven't been paying their invoices on time, but you don't. So you're not in the wrong there. You're not in the wrong. Your system's in the wrong. The system does not know that you have issues of payment. Okay. Your system. Finance knows this. So if finance had been in the loop, finance would have said, no, I'm not approving any more credit. But because the data is inconsistent between the sales system and the finance system, you end up giving credit to someone who's not paying their bills. Okay, so that's a challenge with that. Data duplication, okay, another issue. If we design it properly, we don't have to duplicate the data. And this is what happens then. The data is you lose confidence as a salesperson. You're like, oh gosh, I just got my my ass handed to me by my boss because I approved this, right? Now you don't trust the system anymore. Okay, and this is what happens a lot of times with these information systems is people stop trusting them. Okay, oh, and then he gets a poor reputation. Okay? And I'll give you a really great example is UC. UC's the the sister, brother, whatever it is to Cal State, right? And there's a lot of different campuses. And a long time ago, about 12 years ago, we decided to build a common system for all of our financials and payroll and HR. Okay, it was called UC Path. Well, it's been a disaster implementation wise. I've not been involved with that. I was just part of the committee like 12 years ago to decide we had to do this to save money. So they built the system and people weren't getting paid correctly, myself included, by the way. Like I get my paycheck and it was like a tenth of what they owed me for the pay cycle. And you only get paid once a month there. Well, you only get paid once a month here too, I guess. But anyways, you got to wait a month for your paycheck. Well, that's a problem. Students weren't getting paid. Employees weren't getting paid on time or correctly. There were some people who were getting overpaid, and so then they were having to refund the money to the treasury, right? This system got a horrible reputation, and at that point, I think 3 of the UC campuses were on it. Now there's about 12 campuses on it, and offices and whatnot. But they had to fix those issues, and it was a long time coming. This, like I said, this is something started in 2007 when I worked for UC as a staff member. Okay. It took that long to get to the point where they're just now getting all the campuses on it over the last year or so. It had a poor reputation, still has a poor reputation, and I make fun of it in my class, and I know that people know what I'm talking about there. You guys probably don't know what I'm talking about, but it's basically like the PeopleSoft we use here, the MyCSUSM. Okay, very important system. Nobody trusts it. Okay. All right. So we use databases to organize data and track the data that has different themes. So there's some examples. I already gave you a couple examples of the different themes of data that we do though, okay? But database management systems, that's how we actually create databases, process them, and actually administer them. I'm gonna ask a question. Which of the following are databases? Oracle, MySQL, Microsoft SQL Server. Anybody? Which one of those are databases?
Just Oracle.
None of the above. They're database management systems. A database would be my student information, my financial information, my HR information. Okay? But it's common. Everybody thinks Oracle's a database. It's a database management system. Okay? But they're all database management systems, the ones I mentioned. Okay? And these allow us to actually interact with the database. Okay? Without it, it's just a file containing some data in it that's disorganized. Yes.
Is there kind of a hierarchy with that? Like if each individual UC campus has its own database and then it pings others for information? Or is that all?
They're basically using Oracle's financial system, and it's got its own database. It's got different databases, but they're not by campus. It's just based on subset. I used to work for Oracle's group that makes these systems, and it's pretty complicated to explain, and I don't want to try to do that here. But every campus is on the same system. The way they log into the system is different because they all have their own authentication. Like we have our own IDs. UC Berkeley has theirs. UC Riverside, UCLA, they all have their own. So the way that you log in, you go to the same website. It then says which campus are you. You click on it. It takes you to your own login, but then there's a lot of things that happen on the back end using APIs, which is something we'll talk about in a few weeks. APIs, but that's the only difference. Aside from that, it's the exact same system for everybody.
I guess I mean, is there kind of a hierarchy with these central data hub, where one database encompasses the data from all campuses, or is it individual databases that sort of
It's a central hub. Yeah, it's a central hub. Yeah, which that's just a byproduct of the way that Oracle financials work. With Oracle financials, it's a monolithic application. Some of the more modern enterprise systems are more microservices. So you have a little tiny piece of an application and it has its own data store somewhere. So then you can break it up and split it across. With Oracle and big enterprises, I know, I'm sorry this is getting off track here, but we're going to talk about enterprise systems in a few weeks. And enterprise systems generally have to go on big, expensive computer systems to run it. Okay. And Oracle is one of those examples of that. You can't run Oracle on a laptop, Oracle Financials. You can't run it even on a small server. When Oracle runs it for their customers, they generally have I think it's 8 servers per customer. So a customer has to buy like $1 million rack of servers in order to run it. Okay. So it's pretty expensive, which is another reason why when we did this project a long time ago, we were faced with, at the time, all the campuses had different systems. This is relevant to the class, I'll mention. It's just a little ahead of where we are. Every campus had its own financial system, its own payroll system, its own HR system, and they were all different. Some of them were on mainframes, and mainframes are no longer supported. The programmers who worked on mainframes are dying because they're so old. I mean, we're talking my grandparents' generation or even older, okay? So these people are dying off, and none of you probably, do you want to go do mainframe programming, anybody? Is anybody interested in that? I don't want to knock it if anybody's interested in it, okay? It's a dying career. There aren't many people who know it anymore. And a lot of mainframe people have switched to more modern technologies if they were younger, and if they were older, they've retired or they're dead now. I hate to say it, but so companies and organizations have to move off from these mainframe applications, or it's very costly to find a consultant to keep maintaining it for them. Not to mention the technology is very old. So the problem with moving an enterprise system to a new platform is it's very costly. I mentioned, for one customer, it might be $1 million in equipment plus the cost of hosting it. Then there's a software which can run many millions of dollars. And for a large organization like UC, it could be like $50, $100 million. I don't know. That's probably the reason why Cal State San Marcos hasn't replaced ours. Ours is pretty old, but how can you do it? It's too expensive, right? So what they did was they split it. So now there's a HR one, and then there's one for your student stuff, and it's separate. When I log in, I have to click the one I want to go into. It used to be one. When I first started, it was one system. We outgrew it. We grew too big for it. Okay. So in their case, what they did, they went and said, and I was part of this working group. This is early in my career, and we were talking about things, and Berkeley said, well, we've got this brand new data center we built, okay? and we went to it. It was a really nice facility. It was on par with something you'd see at Google or Facebook. Okay, really really good investment in it. The challenge was UCR's was in the basement of what's now the medical school building, on these tiles held up by jacks. Every time we had an earthquake, the whole room would do this, okay? And all these big expensive machines would be doing rocking back and forth. Okay, we also had problems with flooding in the building. Okay, we would have pipes burst, and one weekend we came back from the weekend. It was a long weekend. Someone had forgotten to close the safe where all the backups of the data was. Okay, and the entire server room was flooded to about here, as well as the tape vault, which was at a lower elevation. And if the door had been closed, it was waterproof. Someone forgot to close the door. So all the tapes up to about this level were ruined. All the data was just completely ruined by the water. Okay, so as part of that, all these things came about, and that's why we ended up saying, hey, well, we could save a lot of money if we all banded our budgets together to build or buy a system for everybody. And then we all learn the same thing, and it's more seamless for the students and everybody else. So that's what happened. The problem is the university outsourced it to a company that wasn't qualified, from what I understand, and they failed. So then they hired another contractor who failed, who hired another contractor, they failed, and then they ended up with someone who actually was able to get it to the point where it is today. That's the risk of any type of enterprise system. Now, I will also say that for those of you who are not MIS majors in the room, this is intended for all of you. And we'll talk about this in a few weeks, but it's critical that non-MIS people are actually driving the decisions for these things, not just the MIS people, because the MIS people, and I can say this because I'm one of them, we have a tendency to go after the shiniest object that we see at that particular point in time. Okay, and it may not be the best solution for the business. And quite frankly, I don't understand payroll. I had to understand a little bit at Oracle because it was it's one of the hardest processes in a business to run. It's the most critical. People don't get paid, they're not happy. Okay? When payroll is delayed, people are upset. It affects them. So it's got to be critical. It's got to be done right. If I'm not a finance person, I don't understand payroll. Okay, so we need people like payroll people to understand it for us. Okay, so if you're not an MIS major, if you take nothing out of this course and you absolutely hate me as a professor, I hope that you take away this, that you should be involved in every decision relating to technology in your organization, period. You should give input, even if you don't understand the technology itself, you should be giving the business inputs of how to do your job and how it will help you. Because if the system doesn't help your job, what's the point? Okay. All right, so there are different types of DBMSs, getting back to that. Okay. I mentioned Microsoft SQL Server and Oracle. Those are commercial options, meaning you pay for them, you purchase a license, you lease a license, whatever it means. It means you get a license to use the software, as long as you keep paying for it. Okay. Another option is an open source. Can anybody tell me what open source means? Yes. The first part is correct. So everybody gets to look at the code, can make modifications to it. Some open source is free in terms of cost. Other open source, it does cost you to use it. But generally, it's freedom it's free in the sense of freedom. Now, a lot of open source today is free, but there are some things that are not, like especially free in intensive use. So if you are an enterprise making commercial profit, some open source software can't be used without paying for a license. Okay. If you're using it for nonprofit purposes or not to generate revenue, then it's generally most of them are actually free. But it really depends on the license, and there's many. And this is where it becomes a legal issue, and legal and a lot of big companies is scared of open source for this very reason, because this company is no longer in business, or they changed their name. They own the patent to a particular technology. And there was an open source product that was claimed to be built on this technology, or derived from the technology, I should say. And they sued IBM and all these other big companies to try to get money. Okay? And I think they may have been partially successful, and they got some of these companies to just pay them off for a license. Okay? It scared a lot of people away from open source for a very long time for that reason. Now, those patents have since expired, so it doesn't even matter now, because the patents on that particular technology are more than 20 years old. So it doesn't matter anymore. But at the time, this was a big deal. And there are still some places we probably can't use open source, like the FAA used to have a ban on it because you're dealing with human life. Okay? So they wanted a vendor who would stand behind their product. But open source licenses, that's what allows us to use it in the classroom here. Okay? We use, and when you do the labs and stuff, we use MariaDB, which is just a derivative of MySQL. So Oracle owns Oracle, and they own MySQL. They got MySQL when they bought another company, and MariaDB came about because the people who created MySQL originally didn't like how Oracle handles their licensing and customer support and stuff. Okay? They didn't want a big company controlling it, so they forked it. It's called fork. When you take MySQL or any product and you say, I'm going to build a new version with a different license. Okay, so that's what happened with MariaDB. So we can use MariaDB. They keep enhancing it. Oracle enhances MySQL. They're kind of doing this in two different directions. The overall technology, though, is very similar, so they're compatible with one another. So, okay. The third one here is PostgreSQL. I don't think anybody here is going to use it. It's another type of free database. A lot of smaller startups use it because it's free. Okay. Now, how do you access the database management system? Mac, you really have one choice. Okay? Well, okay, you have two choices. One, you can use this program, which costs about $50 to license. If you wanted this, again, this is if you want to do something graphically. The other choice is you virtually run Windows or run Wine or something to run Windows apps on your Mac, which is possible to do. Okay? On Windows, you have two choices. HeidiSQL is free, and that's what we have on the lab computers here and out in Cougar Apps. You can use it. It's free. It's easy to use, just like using Word or something. Okay. And then Table Plus has a version for Windows. I haven't tried it, but that again costs money. And by the way, those are links to them if you want to download them. Now, in a DBMS, we do things like read data. We search for data as part of read. We insert data. We're creating new data. Okay? We're modifying existing data, or we're deleting data. Those are really the basic operations that we can do in a database. We use SQL or those graphical programs to do these things. Okay. If we're using SQL, it stands for Structured Query Language. It's an international standard. Here's the deal. You learn SQL. It doesn't matter what database your employer uses. It's the exact same language across the board. So if you learn SQL and you start using MySQL, with very few exceptions, I mean, I'm talking not common things, but uncommon things might be a little different. You go to Microsoft, company that uses Microsoft, and their SQL is going to be the same SQL that you use for MySQL or Oracle or whatever. Yeah.
So that means if you're looking at each of those database management systems, the open source ones, it doesn't matter which one like you have installed if you're learning it.
It doesn't really matter. Yeah, it's just the reason why I have you do MariaDB is because there's a pre-built appliance out there on Google that you can download. Well, not really download. You can set up, and it takes about 2 minutes to turn it on, and you immediately start using it. You're in my database class, right? And you are too. Once you get set up in Google and you figure that out, right, and you turn it on, as soon as it launches, you can start using it. Everybody in class was able to use it. Maybe one person didn't tell me, right? Even though I asked, one person didn't actually do anything because they didn't tell me it wasn't working. So, but in theory, if it works, 2 minutes, you can be up and running and start practicing SQL. Yeah. Oracle, on the other hand, that's not going to be something that you just go click the button and it goes. Oracle takes a long time to install. You can't do it the same way. You've got to have a pretty powerful machine to run it, and you got to then go do a bunch of post-install setup. Yeah. Right. Any other questions about that before going on? Yeah.
I don't exactly know if this is relevant, but going off of that, is there any, because you said a lot of them are centralized in a centralized data center, is there any typical system where they decentralize it and use remote processing power like they did with cryptocurrency and Microsoft?
So not distributed in the sense of like cryptocurrency where it's running on individual machines. Some companies might do that sort of thing for a specific type of database. It wouldn't work well with a relational database just because of the architecture. But cloud-based systems, Amazon, for example, has Aurora. Has anybody heard of Aurora or RDS? Ever heard of those? Amazon. They're basically database services you can get out in the cloud. You point and click, ask you a couple of questions, you hit submit. A minute later, you have a fully functional instance that you don't even have to run. You just connect to it from your SQL client or your graphical interface. Okay? There's something like that. And I don't want to go too deep here because I don't want to bore the people who are not MIS majors. I want to be respectful of people who are not. Okay. Those of you who are not, do you want to hear this? Because those of you who are not MIS majors, I don't know who's MIS majors in here. Okay, this is very brief. I'll make it abbreviated. So eBay and PayPal, you guys all know that. You shop there. Okay. PayPal had an issue where they were running a relational database for all payments. They had an issue at one point where they scaled to the maximum capacity of what you could buy hardware. You couldn't buy bigger, faster hardware anymore. It didn't exist. Okay, so we had to go and split our database up, and this is the thing that always makes people laugh in my class. I'm going to say it. Okay, get the laughing out. We had to shard the database. Okay, so we had to do what's called sharding. Get it out of your systems. Okay. All that means is the database was too big. So say this is one window. Okay. When they built the building, it was fine, right? But now if this window broke and I need to replace it, I couldn't pull this whole section out and take it through that doorway. It wouldn't fit, right? I couldn't get it around the corner even if I could get it through the door. So how do I make that happen? I take a hammer and I bust the window, and now it's sharded into a bunch of shards of glass. I take each one of those pieces of glass and I go find a small computer and I put it on the small computer. I take the next piece here. Now I have to remember how those pieces fit together, right? So then I take a picture of it before I take it apart, and it's a map, and that's the map my application uses to find where the data is on all the different computers. That's a way of doing it scalability in a distributed fashion. That's what we had to do at PayPal. But today, companies, that is one way of doing it. It's very complicated. There's a lot of challenges with it. In fact, Walmart Labs here is in Carlsbad. Walmart, if anybody's looking for a job, by the way, Walmart Labs is in Carlsbad. It's their main lab facility for Walmart for all the new technologies they're doing. It's not a store or anything like that. It's actually like a tech company. But they have marketing roles and tech roles and product roles, all sorts of stuff over there. Okay. They are trying to figure out how to do this sort of thing to shift away from maybe a relational database to something else. Because there are databases where you don't need to shard things. Okay. You just use a different type of database, which is designed for that sort of thing. Because relational databases have been around for over 40 years. So it's like the great grandfather of databases. Okay. All right. Hopefully that wasn't too boring for those of you who are not MIS majors. Now, this is SQL. Now, I'm just going to explain this a little bit. I know it might be a little hard to read. You can look at the slides. Okay. I posted already. All right. The first one is just inserting data into a department's table. Okay. And it's given the data. So the data is finance, HR, IT, legal, marketing, and then those numbers are their codes. That's the equivalent of that table I had for departments. Okay. Then once I've inserted the data, I use select, and it shows me everything in that database table. Okay. So you can see I entered it, and now I output that same data after I entered it. Okay. Then these are examples of some other tables, but these are not the data. These are the designs. So this is me going out in SQL and saying, tell me what the design of employee is so I can look at it. It doesn't show me any of the data. If you notice, it's just employee ID, last name, first name, etc., and it's got the metadata. Okay. I can also use SQL to describe what a table looks like. I could then run this command on, say, employee, and I would get a list of all the employee data, salaries, what department they're in, etc. Okay. And this is just another example of that one above. I will show you a real example here in a second. Here's some more SQL queries that are samples that are very simple ones. They're not complex. You can get really complex, okay? And I'll use plain language for this. It's called pseudocode. It's not actual SQL. I think it'll be easier for you to understand. Show me all employees in California, but not in San Diego, who make more than $50,000 a year, are not hourly, work in the finance department, and have been here longer than 3 years. That would be a very substantial query for me to write in SQL, but I can do it. Okay? So if my boss comes up to me and asks me for that data, I can go and pull any data that they want. Okay? The alternative is I go around the office, okay, and they say, hey, can you get me this data? And you say, no. Can you get me the data? No. And I go around, and finally comes someone and says, yeah, I can get you that data, sir, and I'll get it for you in 3 weeks, okay? I can get it myself, and I can get it in a matter of minutes, okay? So that's the benefit of learning SQL is when your boss asks you for your report, you don't have to wait for some technology person to go get it for you. You can actually just go get the data yourself. All right. Here's another example. This one here is a little more complex, but this is actually creating the database from scratch in the tool, okay? And then we go in and we create users, and we give users permissions. And one of the reasons we have to give different permissions to people is, let's say you're an accountant. I don't know if you're an accountant or not, but let's just say you're an accountant. You should be able to write data to the accounting database, but you should not be able to delete data from the accounting database, or we have another end run on our hands, and SOX prevents us from doing that. Now, you on the other hand, you're the IT person. You ought to be able to look at the data if needed, but you can't change it. okay? Now, let's just say you're not a database person at all. You're the system administrator. You can delete the data, not from the database, but from the system itself. These two cannot, but you also can't see the data. You can just delete it without looking at it. You see what I mean? So he has the right to delete the files. He has the right to control what you have access to, but he can't give himself access. That's called separation of duties, and it's required under the Sarbanes-Oxley law. Okay? And that's because of Enron, the scandal there, and the scandal with MCI WorldCom. Okay? The old joke was, I told you to send the documents to the feds, not rip them to shreds. Okay, so that's to prevent that. So you give people different permissions based on their role in the organization. All right. Here's another example here. This one here, this is actually from a student of mine. So they did a project where they had to create a database, and in this one, they said show, create, table, and then theirs was called towns. Okay. And what this does is this spits out the SQL that was used by someone else to actually create the table in the first place. Why is this useful? Let's say you create a database and now you need to go create another copy of it somewhere without the data in it. You just want to create the structure, right? A new database for some reason. You don't have to go figure out what someone did. You can just go spit out what was the SQL that someone used to create this database? Boom. You could then copy and paste that into your own server, run it, and you could get the exact same thing that they have. Okay. I think this is a duplicate of the previous one. Now I'm going to talk, before I show the demo of the relational stuff, let me real quickly talk about some non-relational. So I mentioned MongoDB. So MongoDB, and if you do the lab, you can actually go in, you can see some real screenshots of I'm not going to take the time of class to do that. If you're interested, you can go in there. But what's cool about MongoDB is it's like a document, say a Word document. And everything about that particular item is in one file. It's not in a bunch of tables, so then you don't have to piece it back together, okay? There are things like key values. So key values look like this. Okay? Animal, cat, color, red, that sort of thing. Okay? Or they could also look like this, color equals red. This is a key, and these are values. Okay? That's what a key value database at its heart does. Okay? Those two particular examples there, they're used to speed up applications. Okay. So let's say I have a web application, I've got an e-commerce site, I'm selling things. That allows me to speed up, okay, those types of databases. Okay. The last one, graph, or sorry, the third one there, graph and column. I'm not really too familiar with graph. Okay. All I know is it's an enhancement upon what relational offers, along with a lot of other features, but they're really new. Okay. So I have no knowledge of them. But column, okay, Cassandra, HBase, this is useful for doing data analytics. Okay, so if you've heard of data warehousing and stuff, those types of tools are used for data warehousing. You've got a big collection of data and you want to do things to it to understand it. Okay, and we should cover that towards the end of the course when we talk about business intelligence and things like that. All right, so we'll skip on here. All right, so now I get to show you my database here. All right. Okay, so I use this platform called Google Cloud. I've posted in the classroom how you can use this yourself. Okay, if you plan to use this, you do not know how to set it up, you're not comfortable with setting it up, you should come to my office hours and I'll help you set it up. It only takes a couple minutes to get your coupon code. Okay, I would rather do that than you just guess, try to load it to your school account, which will not work, by the way, and then I have to go through a whole bunch of steps to go get you new code. That takes me a lot more time than if you just came to me in the first place. In order to use this, you will need a personal account and your school account. You can't, you request it with your school account basically, and you redeem it using your personal account. The school's email system does not support redeeming it. It will let you, and then it will give you an error, and then you've lost the code and you have to get a new one. Okay? It takes me a lot of time. There's, this class isn't that large, but it does take me a lot of time to go request those codes, one-offs. Everybody can go request your own if you're interested in doing any of the labs with Google Cloud. Okay? You don't have to, but if you are an MIS major or something along those lines, I strongly recommend it because you're going to be using this in my other classes. You might as well get familiar with it now, all right? I created this instance for my database class on Monday, okay? This is my database server. It is running out in the cloud. This is not my own hardware. I basically get this free. using the credit that I got for this class. Okay. I can start it up, and this is a virtual server. I can't touch it. I can't see it. Okay. But it's running somewhere up in the Bay Area in one of those massive Google facilities that I will never have access to. Okay. I can't even talk my way into one of those facilities. In a second here, I'll be able to connect to it and show you some of the database stuff. Okay. Some very basic things. It's running. Okay. That fast to turn on a server with a database on it. So I can connect to it remotely here. And in a second, we will have a, I'm gonna have to make this a little larger so you can actually see it. Well, actually, that's probably fine. All right, so this is a MariaDB database, which is I've only created a basic one simple database, and I think I only created one table. I don't even think I put any data in it yet. All right, so this is what the command line looks like. So anybody do the command line lab yet in this class? Okay, that one you play a game, and you're gonna use an interface like this. And you may hate me for it, but it's an easy lab. I can't tell you enough. That and the cybersecurity one are like the two easiest labs. And then I will be a very happy professor that you did it, okay, because the command line is so critical if you're using SQL and things like that. Okay, you have to learn it, and we don't teach it in any other class except for this one and the 411 database class. Okay, so if you don't learn it in this class in that lab, or you don't do it in the 411 class, you will never learn this because it's not taught anymore. Okay, yes. No, you don't have to. So that's the predefined, ready to go MariaDB images from Bitnami. Okay. They go package it up, they install the software, they image it, they save the image to Google, and all you have to do is point and click. It's already installed. That's why it doesn't take very long. All it is it's copying it from a repository, like a library. Think of it like a library, and it's saying, build me a copy of what's in the library. So it's kind of like checking out a book to you, and you turn it on, right? So it's kind of like now you got the book in your hands and you can use it. That's the same concept here. So Bitnami just packages things up for Google, Amazon, Microsoft, etc. Okay. Makes it easy for you. Now, my database server is already running on here, my database management system here. So don't worry about the commands I type, because if you're not in 411 right now, do the lab and these commands will make sense, okay? I could spend an entire class teaching this stuff. For those of you who are not MIS, it would be a complete waste of your time. Okay? I want to be respectful, right? So what matters though is I have a server when I can see it's running here. Okay, this is like my task manager on Windows, activity monitor on Mac. I can see what programs are running here, okay? And I'm running my database, okay? So last time I was in here was a couple days ago. I logged into, I have to find my password. MIS4, here it is. Oh, no. I don't want that up on that screen. Then you all know my password. Oops. Oops. I clearly fat fingered it. Okay, now I'm on the database server, the database management server. Now, I did some things the other day. Oops. Oops. These are the databases that I've set up on this database server, okay? I only have one that's actually usable by me, okay? It's test one. So I tell it to use my test. Don't worry about, oops. I tell it, oops, don't worry about the commands I'm typing for this class, okay? But if you want to learn SQL, you'll want to learn these independently, okay? So I've got this database, okay, and I can say, show me all the tables in the database. There's only one table. Okay? So I told you can describe what the table looks like. So I can say, tell me about dog. Okay. The dog table has two columns, dog ID and dog name. Dog ID is an integer. Dog name is a variable character string. Okay. Dog name can be null. Dog ID cannot. Dog ID is the primary key. Okay. Yes.
What are the numbers in the parentheses next to int and variable character?
Oh, so it's like 11 bytes. So 11 characters basically. Yeah. Yeah. And then the varchar is up to 40 basically. Yeah. 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 So this is describing dog. Now, if I want to look at, I haven't actually inserted anything into dog yet. So I can go into and say, I'm going to pull up the lab here to show.